Hi, good afternoon, James, and good afternoon, Dr. Chen. Okay, my name is Zhennan Zhang. I'm Dr. Chen's PhD student. I'm so happy that Joel, you are interested in the project in our lab, and Dr. Chen told me to give you a brief introduction about our current project. Our current project, this project is the title of this one is engineering architectures of 3D printed materials for tailored performance. And so the original motivation for this study is from the electronics. And there are some requirements for the flexible electronics. For example, the bendability, stretchability, and conformability. But current traditional materials are not good enough to realize the function of the flexible electronics. So we are going to use a structural strategy. Another word is a lattice structure of materials to realize some function that the traditional materials cannot achieve. So in this study, we use a kind of gray key based architecture materials. So what is gray key? Gray key is our design source, and it's a kind of Asian art. It has two features: the continuous and the repeated. So it can be regarded as a kind of lattice structure. So in this study, we have the hypothesis that the gray key geometry, we can use the gray key geometry to design some architecture materials. And this kind of architecture materials can realize some unique mechanical properties, especially for the flexibility. So the motivation of the study is to realize that the interaction between the H&R, grid key, and the flexibility. And the objective of this study is to quantify the unique mechanical response of a grid key inspect structure and design some novel architecture materials with multifunction. So this is the kind of grid key structure. And in this study, we have three designs based on grid key. We call it N1, N2, and 3. Three kind of basic lattice structure. And then we use these three designs to design and to manufacturing some uh, 3, 3D 3D structures, and then we study the mechanical properties of this kind of structure. The first one is the bendability study, and based on this structure, and we use a 3D printer to print the sample. With our sample 1, 2, and 3, and then we did some experiment, 3-point bending experiment, to study the mechanical properties for this structure with a bendability structure. And we also did some simulation for the structure. And then another study is the stretchability, and we use this kind of three kind of structure to study the stretchability of of the Greek key spared structure and to realize the tunable properties of this structure. In some video, and from this study, we can realize we can achieve more than 500% stretchability, and from a very brittle basic 3D materials. And this kind of basic material, the stretchability of this kind of materials maybe only below 10%. So from the bendability and the stretchability study, we can know that we can use the 2D structure to realize some conformability. This kind of conformability, I printed a sample and to do this demonstration. It can cover some very uh, in shape, in shape, in shape atom uh, very well. So let's study the bendability and the stretchability um, have almost done. So what to do next? What to do? What to do next? And what should we do for your project? Yeah, from previous study, we are very interested in another direction of the structure. It's the outer plane compression. It's a load direction, and actually we have done some preliminary work for this outer plane compression. We have in this study we also introduced another structure, honeycomb. You know, honeycomb is a very traditional material. So we are going to use our structure N1, 2, and 3 to compare with the honeycomb structure. We mainly focus on the auto plane compression, and actually in-plane is also very interesting, but it's not that important as the auto plane compression. And we have printed some sample using HP printer, and we have done some experiment, compression experiment, but actually the sample design is not that good because some gap of the sample has been blocked. So we just did the three experiment, N2, N1, and honeycomb, and we still we are and then we hope to get a very good N3 structure. So we did some new samples with the capstone, with the capstone student, and the sample is really good. Yeah, yeah. And after the several attempts, and I think for the new project, and we can, but the samples and the data are not enough for the experiment. So that's what we will do in your project. We will print maybe more samples to finish the project, and maybe we will write a paper based on this new project. After several attempts, I think um, we have we have know how to print a sample in good quality. What's the constant? What's the shape? What's the size of the sample? So I think you don't need to, John, you don't need to worry about that. We don't have enough result when the semester at the end of this semester. So what to do? What kind of sample we will print in the new project? This outline I wrote last I wrote last year. This is outline I wrote last year and for the potential paper, but at the time we have to switch to another project because we have some new work to do. So this work has been delayed for a very long time, and at this I think in this semester we can pick it up. Doctor, we can pick this work up, pick up this work. And I have shown that the comparison between honeycomb and 1, 2, and 3, and maybe in the future in your project, maybe print some other uh, samples with different size, with different beam size, and with graded graded design, and with some different biaxial biaxial design, and with different loading rate, and with some static experiment or some high velocity experiment. Or we can also do some pre-curve structure. I have done some preliminary simulation based on these three ideas. The doctor also asked me to write an outline, and I found I have done some previous work from the upgrade simulation. I think it's good to talk, and it's a good chance to talk. It's also a good chance to talk. And there's some citing from the up course, some parameters, Young models and Poisson ratios. There's a comparison between N1, N2, N3, and the honeycomb. There's some deformation images, deformation, simulation, deformation, simulation, deformation images. I also did some pre-curved. What is pre-curved? I gave a pre-curved or pre-buckle to the sample and want to study the beam. Actually, we want to control the, the, the buckling direction of this beam, and we want to see whether we can achieve the tunable mechanical property with some simulation result. And then I have also done some uh, simulation for different beam size. It's from N1, the beam is from 0.5 to 2. There's some result, some normalized results, some simulation results. The last one is the Baxel. And I will, because we want to realize some tunable mechanical properties, and our structure can be pre-striped to a string, and then we can compress it to get the mechanical properties with some result. And I also did some uh, impact with different velocity, loading velocity, and there's some setting different velocity, initial velocity, with some impact result. Yeah, I think for your project, we are interested, you are determined to join this project, we can talk with Dr. Chen and print some sample with, with direction, with the basic idea based on the simulation result, and we can print some samples to do the experiment. And it's a research plan, and at the beginning you may need to know what is a structure, fractal structure, and anticipation, and then some very basic concept, some very important concept, and then we can do some experiment. We can design some sample and to do some experiment, use a 3D printer, and finally we will process the data, and you can prepare the report for your class. I have some experience with to experiments to get a student. This is a capstone group, and they did a similar job with this project. Mm, but they don't have a project, and they got a very good result at the final uh, capstone show. And there are some lower high school students. We worked together with a very good atmosphere, and we hope you join us and we can do some interesting research together.